Okay, so today is our last section of this chapter, chapter 12. We have one more chapter to go through, which is data, so chapter 13, and then we're done with regular geometry. Okay, so this last section is called spherical, similar, and congruent solids. So to have a similar solid, we use that scale factor, also called a similarity ratio. So ratio looks like this. And we can cross multiply to see if they are equal or to find a missing value. And we've done this before. Now, these are all the ways that you can do this. And then we're going to go through some of these. So we're going to kind of have to keep this in mind. Let's see here. So H over H2, and then this would just cross multiply like I'd say. We've done this before. So let's just keep going here. So here we have the scale factor of 5 to 3. So anytime you have the scale factor, I write it immediately. Now, I'm going to find X, Y, and Z. So to find X, in this 5 to 3, that means big to small, because the bigger number's on top. So if I'm trying to find X, I would use the 10 and the X and cross multiply. So 30 divided by 5 is 6. That was easy. And then let's try Y. So use the same scale factor. And this time this and this are corresponding. They are matching. Y, this one you'll have to use your calculator. So 3 times 12.5 divided by 5 gives us 7.5. And then last one, 15 corresponds to Z. Cross multiply, what is that? 45 divided by 5. Did I say that right? Yeah, Z is equal to 9. All right, so that part was super easy. You guys should know how to do that. Okay, so this is where it gets a little bit weird. So this example 4 has to do with volume. Okay, so if they're giving you the volume, so the volumes itself, you would have to take the cubed root. So you can find like the sides, but right at this point, we're just trying to write that similarity ratio. So it's here they are. And then it says, what is the similarity ratio of the smaller to the larger? So smaller to the larger is important. So my smaller, and we're going to have to use the cubed root because it's been cubed over the larger. And let me show you how to do that on your calculators. It's been a while. Okay, got to make sure you can see this. You can't see this. Scoot him over. Okay, so you have to hit the 3 for cubed root. And then you're going to hit your second key and your caret key. And now you can do 512. And that's 8. So that really means 8 cubed equals 512. So this next one, 3 second cubed root of 2197, and that is 13, and we are done. Okay. Next. This one is talking about surface area. So surface area we can square. Now, the weird thing about this is the larger is 829. So here we're going to compare this to this and then this to this x because we don't know it. So since it's squared, area, you're going to say 16 squared over 12 squared is equal to 829, which we don't know what x is, and cross multiply. So 12 squared, 144, times this, divided by this, and then your x should equal, punch that into your calculator, 466.3 units squared. And that's how you do it. So I guess it's kind of hard to realize or try to figure out, do I need to do the square roots? Like here you might want to do the square root, but we didn't have the other one, so we didn't do it here. But since to find, according to, let's go back over here, and we're going to go back here in a minute. It says square to find the ratio of the surface area. So what example was that? Example 5? Cube it to find the ratios of the volume. So that was example 4. Back over. This one, we are going to kind of cubed root it. So since this is volume, we need h cubed, 6 cubed, 80 pi over 270 pi. Now before I cross multiply, I can simplify, get rid of this, and get rid of the 0. So h to the third times 27, put the 27 at the beginning, is equal to 6 cubed, so 6 cubed times 8 equals 1728. Finding h, so I'm going to divide by 27. H cubed, 1728 divided by 27 gives me 64. Now I need to do the cubed root of that just to get my h. Cubed root of 64. So again, can you see it? 3 cubed 64 is 4. So h is equal to 4. Example 6, again, that has to do with volume. So if we wanted to flip this back over, example 6 has to do with volumes. So that's example 4 and 6 right here. Okay. Next, it's talking about if they're congruent. Obvious, if they're congruent, they're going to equal each other. That one's, that's that. This next one, okay, so we're going to determine if they're similar, congruent, or neither. So just set up your ratio. So here you can just set up a regular ratio. So I could square it, I could do whatever, but I'm not trying to find volumes and I'm not trying to find surface areas. I'm just trying to see if they are similar, congruent, or neither. So I'm going to set 12 to 4, because I just did this ratio, is equal to 27 over 9. And cross multiply. 9 times 12, is that the same? 9 times 12 is 108. And then 4 times 27 is 108. So yes, these guys are similar, because they are equal to each other. Okay, yes, I could have written this as 12 to 27 is equal to 4 to 9. It's the same thing. It's the same thing. You can write this different ways and still get the same answer. This one here, we need to get rid of these values here, because if you don't get rid of, this is not, sometimes when they give you stuff, they're not true figures. So this was an example we pulled, didn't realize that this was totally will mess you up if you use that part. So we're going to just compare these two. So I'll do 8 to 10. I like to mix it around. What goes with 8? 6 in the square root of 2. What goes with 10? 9 in the square root of 2. Okay, we can cancel that out, simplifying it first. Now we're going to cross multiply. 8 times 9 is 72. 6 times 10 is 60. So this is neither. This is neither congruent, similar, neither similar or congruent. So neither. And that is that. All right, so I think it's a Google form. If you have any questions, let me know. You have a review on Friday and a test on Monday.